I'm what they call a developer advocate. I work for IBM in their cloud data services department. I'm not trying to sell you anything, straight up. All I'm really kind of hoping for today is that maybe some of you guys will go back to your lunch break tomorrow, maybe try this out and just have a go, see if I can inspire a few of you to do that. I have a little bit of a sore throat, so if I stop and take a drink, just bear with me a sec. But yeah, today, I just want to talk about building real-time apps. And when I say apps, I don't mean necessarily iPhone apps or anything. I just mean real-time things like websites or maybe iPhones. And more specifically, building them with something called RethinkDB and node.js. So this is obviously a JavaScript meetup. I'm guessing that there's a fair few people here that are familiar with Node already. Has anyone seen or used or heard about RethinkDB at all?
Yeah.
In any kind of meaningful way?
Yeah.
Just a little bit. Yeah, there's always a couple of people. Never many people. Okay, so what I want to do, I just want to start off by talking about real-time apps. What they are, the kind of problems that you're going to be looking at if you're trying to build one of these things at any kind of scale. Introduce RethinkDB, talk about how that can help you solve these problems, and then have a look at Node, see why we think Node is such a good fit for building these kind of things, and then we'll look at a bit of code, and there's a demo in there, and at the end there's a bit of an interactive demo as well. So if you all have some kind of smart device that can get on the internet, that would be really cool. So let's get started. The first thing then that we really need to ask ourselves is what is it that we mean by real-time apps? And for the purposes of this talk, there's one key characteristic really that defines whether your app is real-time or not, and that is whether you are able to push data to your users either when they require the data or when this data becomes available. And this is a bit of a departure from the kind of more familiar model of a user requesting and then pulling data from a server and then using that to render a front end or do whatever it is we do. And what we really want to do is move to a model where you can combine both of these approaches. So maybe on first load of a page, you would pull all of the existing data from the server and do whatever you need to do. But then after that, we want to push any new data to the user. And a good example of that is Facebook. You go to Facebook, you load your homepage, you pull down all of the outstanding notifications, you pull down all of the latest posts, your homepage renders. But then after that, any future updates, any new notifications, or any new posts that come in while you're looking at the screen, they get pushed to you. And that's what we're in. So here's some real-time apps. I would imagine that most people here probably use some kind of real-time app every day. Even if you don't even realize you are, you probably do. And there's all sorts of different use cases. You can see that we've got social media, we've got kind of collaborative working apps with Google Drive, like live streams, like on BBC and all that kind of thing. Obviously, chat with things like Slack, and then we can expand this further to online marketplaces, online gaming, even things like connected devices, like reading live data from sensors and things like that. People use sensors to check for temperature and humidity for farming and all that kind of stuff. So there's all sorts of use cases. And going back to the examples up on the screen, we're all quite familiar with these apps, and we know that they're all very polished, and there's a lot of work that's gone into them to kind of get them to where they are. They have a great user interface and all of that kind of thing. But for me, the thing that really pushes them, or one of the things that really pushes them from just being good to being more than good, to being maybe great, is that they do have this ability to push data around, push data to their users in the form of events or notifications and that kind of thing. And it's this which makes these apps feel like a little bit alive, like there's more happening behind the scenes, or there's more happening than just what you can see in front of you. And the users feel like a greater sense of engagement, or a greater sense of interactivity with the app. And also with other users of the app that maybe you wouldn't get this kind of thing that can turn that great user interface that we mentioned earlier into a great user experience. And really, that's what you should be aiming for. If you want to keep your users engaged, you want to keep your users coming back for more, telling their friends and all that kind of thing, then a great user experience is going to do that much easier than a great user interface. The bad news, though, is that actually building these kind of things is a little bit tricky. It's fairly easy to kind of knock something together. It's fairly easy to have an idea, use like WebSockets or something like that to put together like an example, a prototype, that kind of thing. But building these things at a production level, like at scale, is a whole different thing. And the main reason for that is that tracking state in a real-time app is pretty hard. So to expand on that a little bit, traditionally you would have one source of data in your application, and that would be your data. And at any point, you're able to ask your database any question. It represents the current full state of your application. So you can ask it any question, and you're going to get an accurate response. It's going to be a current response, and it's going to be a response that you can really trust, and you can really hang your hat on it and say, this is exactly what's going on inside my application at this time, at any one moment. And because if you are building a real-time app, then it's probably quite data-driven, because that's just the nature of these things. And so if you're wanting to push this data to your users in a real-time fashion, then you're going to end up having to hit your database a lot to replicate that real-time experience. You're going to have to ask, each user is going to have to ask these kinds of questions of your database on a regular basis, maybe every few seconds. And you're going to have to do that even if there is no new data, because otherwise, how would you know there's no new data? You have to keep asking these questions. And the problem with that is that databases are pretty slow. And this approach is called polling, and it's inefficient, and it's clumsy, and it's just we just don't like it. Big reason we don't like it is that it doesn't scale, and scaling is difficult. And this is actually a problem that I came across in a previous life when I was actually a proper developer. And I worked for a sales company. We had a sales floor with customer services and all that kind of thing, and they were using this CRM system that we built in-house. You know how these things go. You start off with something that does this simple thing, and over the years it bloats itself out and becomes something else entirely. But it was a very simple application, really. It was just PHP, MySQL. You read stuff from the database, you wrote stuff from the database, and nothing too clever, really. But it did have some real-time-like features. So we had things like instant messaging, because it was just useful for sales agents to be able to ping messages backwards and forwards. We didn't actually trust the salespeople to send emails directly to clients, so we had to we want to kind of vet them through customer services. So we wanted to be able to send alerts to customer services, like within the CRM, to say, oh, we have a new email that we want you to check before we send it. We want to do the same kind of thing for sales agents, so we could send them new leads, say, well, you've got some new leads because that was a good selling opportunity. And then there was a bit of reporting and that kind of thing. Like, what have you sold today? How has that affected targets? All that kind of thing. And this was a while ago. This was, where are we now? 2016. So this was over a decade ago. And the kind of technology building these kind of web apps was not quite where it is today. And it was a bit cumbersome the way it was implemented. All we did was we just picked a certain interval. So maybe every 10 seconds or something like that, we would make a request, like an AJAX request from the browser. We'd hit some script on the server and say, hi, I'm Matt. Do I have any new instant messaging notifications or something like that? And we do that for each of these different features. And this is done from the browser. This is done per user. and that's quite a lot of requests. Luckily, back then there wasn't really many people using the system, and it worked fine. Really, it worked perfectly, in fact, until one day it just really didn't anymore. The company had expanded over time. We had added more people. New features had been added to the system, so we were making more and more of these requests. And all of a sudden, the IT guys were telling us that network traffic was through the roof, and the servers were dealing with this huge amount of requests, and performance was suffering. And it wasn't just performance in this particular application; it was performance across the whole network. We were really clogging up the network with all this stuff. So, it was quite obvious that something had to change because we couldn't go on like this. But we built these features for a reason. They were useful, and people used them, and we wanted to keep them. So we did a bit of research, and we did a bit of work, and we converted everything over to use something called WebSockets. Has anyone heard of WebSockets? A few people? Okay. So, WebSockets are a permanent connection between a browser and your application. And you can use these connections to push data to your users. And so this meant that we could then start to push these alerts and these notifications to our sales agents when something happened at the application level that meant we wanted to do this. And this was good because that meant that we no longer had to do this horrible polling thing where we had 100 people asking us something every 10 seconds for 5 different things. And it worked perfectly. It was almost instantly. In fact, it was instantly. Everything just improved. Performance was up, traffic was down, the number of requests was down, and everything just improved almost instantly. Until a few hours later, when we realized that there was quite another big problem. And this was because we tried to be responsible developers. Our application was running across a couple of servers for redundancy. We wanted to make sure that if one server died, this system that was integral to the company didn't fall over. So that's kind of standard practice.
Web servers.
Yeah, web servers. Yeah. So this is mainly just it was just a PHP application.
Were these ran clustered, or were they two separate servers?
They were just two separate servers. So for a HTTP application, which is
DNS, that sort of simple stuff.
not even that complicated. It was just behind the load balancer. Nothing.
It's more sophisticated than round robin.
Oh, I mean that's not my area. That's not my thing. But it was just a simple load balancer with a couple of servers behind it. But that's okay for a HTTP application because these kind of things are what we would call stateless. You have multiple servers, but server 1 doesn't know anything about server 2, doesn't need to know anything about server 2, doesn't need to know anything about server 3, or server 5, or server 10. All it does is receives a request, deals with the request, sends a response, and moves on to the next thing. That's all it cares about. And that's fine, because if you do need to scale out, if you do need more power, or you do want more redundancy, you just throw more servers at it, and that works fine. But in a real-time application, it's different. HTTP is what we would call stateless. A real-time app is what we would call stateful. In that connections are permanent, so a user kind of belongs to a server. So you end up, because you're load balancing, you end up with some users connected to server 1, and some users are connected to server 2. So that means if an event happens at the application level, and we want to send a notification for it, if that happens on server 1, we're going to send this notification to everybody who's connected to server 1. But everybody who's connected to server 2 doesn't know anything about it. Same for server 3, same for server 5. And that's where you run into problems with scale. So this meant that half of our sales agents weren't receiving these notifications. But it wasn't even as clear cut as that, because everybody was receiving notifications. It was just people over this side of the room were receiving some notifications, and the people over this side of the room were receiving different notifications. And so it was a bit weird for us to try and figure it out. So we fixed this first problem, the problem with the polling and all the network traffic, but we introduced this other problem which we hadn't even considered. And this meant that to get around this, we had to implement some kind of middleman to help us coordinate the state between It also means that the state of your application now rests somewhere between what is in your database and what this middleman knows about. And if at any point that diverges, then you could end up with a really disjointed experience where some people are seeing one thing, some people are seeing another thing, and so on. And that's because you no longer have this single source of data that we talked about earlier, that we were using to power these alerts and these notifications. We kind of split that. And as a added kick in the teeth, it makes it much harder to debug if something's going wrong because you don't know if the problem's with your database or with your servers or with the middleman. It's just an extra moving part that you've got to try and isolate. And it also makes it much harder to scale because you can't just throw more hardware at it, because if you introduce server 3 into this equation, the middleman needs to know, okay, well, server 3 is now a thing and it lives here and all the linkages need to be there. So you can't just throw more hardware. So yeah, so this was my first real kind of attempt at building something that was real time and production ready and all of that kind of thing. And it was quite a lot of fun actually. From building just basic read-write database apps, it was something that was quite interesting, and it did work, but it caused us enough problems that we're talking about it.
What did you use to manage the website?
So it was Redis actually. We used Redis PubSub so our middleman was built out of Redis. So we just opened a lot of PubSub channels in Redis and put that on a server that was capable of handling plenty of traffic. So that's what we used. So yeah, it was fun, but it was a bit of a pain. So at this point, so I just want to leave that there for now, and we'll come back to that in a minute. So I want to introduce RethinkDB. So this is RethinkDB. Before I dive into this stuff, there's just something that I'd like to kind of address straight up at the very beginning. RethinkDB is open source. You can download it for free and all that kind of thing. But there was a commercial entity behind RethinkDB. They were trying to build a kind of a sustainable standalone business that employed developers to work on it full time and all that kind of thing. And unfortunately, in the last